Now, so you have, okay, you have this question about hydrated zinc sulfate, and then you want to actually do a simple experiment to determine the value of X, okay, in this formula, okay. So what we do is we heat it carefully to drive off water. I think the answers for question part 1 is already given here, okay. Carefully drive off water. A student plays, okay, so all the details you can see, it is heated for a short time, cooled, and reweigh, okay, when it is cooled. So this process was repeated for 4 times. The final results are shown. So you have the empty tube, you have the hydrated. Hydrated means this one, this is hydrated, and the mass after the heating. So this one should be the dehydrated, or we call it anhydrous, okay, without water of crystallization. Now, why was the boiling tube heated and cooled reweighed for 4 times? Okay, why this thing has been done many times? Kiera, can you give me the answer? To ensure what?
Water is all evaporated.
Yes, to ensure water all evaporated. Okay, so to be actually in your marking scheme, they actually write to ensure all the water of crystallization. Okay, to ensure all the water of crystallization is, okay, if you want to use the same term, is driven off. Okay, another answer that is going to be accepted is to ensure that you have a constant mass. Okay, what constant mass? It means the mass without the water of crystallization. So you want a constant mass over there. But I will suggest to actually give this answer because this one is straightforward. Why we do this again and again? To make sure that all goes off. So it means it is understood once it goes off, it is understood the mass is going to be constant. Okay, but if let's say they give you 2 marks for this, then you give both answers. Okay, what are the both answers? To make sure all the water of crystallization is driven off, and we have the constant mass. Okay, so when we reweigh, you will have a constant mass. Okay, so take note of that. So in that case, I will actually just put it over here to make sure you have constant, we have constant mass.
Sir, is the same test tube being heated and cooled, or is it for different ones?
It's the same. It's the same.
Okay.
Reweigh and process repeated 4 times. So when they say process, so it means the same. It's done for 4 times. So it's like something like in the past, I think last time there was a experiment in maybe in your textbook in IGCSE, like they try to actually find out the empirical formula of something. Then they actually heat up the petri dish many times. They open a little bit, then close, heat up again. Okay, I hope you remember this experiment. Okay, they keep on closing and opening and so on. It's the same concept. So you don't actually do it for 4 times. You just repeat the process for 4 times. So to be exact, we don't do it exactly 4 times. We do it until we have the constant mass. Okay, so we are doing with the same experiment only. So here the next one, calculate the amount of moles, okay, in moles, the anhydrous salt produced. So if you want the anhydrous salt, so what is the number that we need to minus here? So you see this is the mass of the tube, and I know that this is going to be my anhydrous. Okay, so if I want the mass of anhydrous salt, okay, I just need to actually get 76.34 minus with empty tube. Okay, so that's going to be the mass of anhydrous salt. But if I want the number of moles, I need to get the mass, and then I need to divide with, okay, the MR of zinc sulfate. Okay, the MR of zinc sulfate. Okay, please someone help me to calculate as well. The MR of zinc sulfate. What do you have?
161.5.
Is this the MR only? Ashley, is it the MR or just the entire number of moles?
The MR.
161.5, yeah. So what, please someone help me to calculate the number of moles.
0.0129.
0.0129. Okay, that's going to be the number of moles. So here, okay, we want to actually find out the number of moles of water driven off by heating. So if you want to actually find out the number of moles of water heated, driven off, you just use this and this. Why? Because no need to minus with the mass of empty tube, because the when you minus, okay, the mass of the tube will be gone. So you can actually minus the anhydrous, so you can actually find the water. So the one that I minus over here is 77.97 minus 76.34. Okay, so your mass of tube will be gone and then left with only water. Okay, and I know that water, yeah, water number of MR of water is 18. Okay, 2 times 1 plus 16, yeah, 18. So calculate for me the number of moles of water. Raphael?
0.09055.
Okay, good. Okay, 0.09055. The others check, yep.
Sir.
Yep.
Many significant.
Okay, this one, okay. I will here check first whether there is specific instruction. If there is no specific instruction, I'll show you one example that has specific instruction. I think I put it here. Let me check, yeah. Okay, I didn't put the question over here. Unless there is a specific instruction, please actually give, yeah, here. You see that I actually put this one where they say all your numerical answers must be up to 3 significant figures. If they have mentioned like that, it means every single thing that you calculate must be 3 significant figures, okay? Everything. Now, if they don't mention, we follow the normal rule, which is going to be as much as possible. Yes, we want 3 significant figures, but if you have, okay, if you have like the final answer, if we still here, we still don't calculate the final answer, I will still suggest, okay, to keep more significant figures, or you can always write down like this. If you are still want to follow 3 significant figures, I think this one is already 3 significant. To be exact, yeah. So decimals, if you have 0 in front, 0.0 or something, then it's still counted as 3 significant figures. Okay, still. So it's 1, 2, 3. Okay, but for this one, okay, you can see that this is already 4 significant figures. So if you want to change, it's fine. Okay, 906 moles. You can keep it like this, 3 significant figures. Okay, but this one, please keep it. Why? Because you are going to use your result. It's much more better if we actually have more values and then you calculate the x value. So here, use your results in 2 and 3. We are going to use this result to calculate the value of x. Now, to calculate the value of x, you just need to separate this into 2. Just put zinc sulfate here, water here. Zinc sulfate is already, you found out that the number of moles, yeah? So zinc sulfate is going to be 0.0129. And then water, okay, EV1, okay, I will suggest to use this. Okay, once you use this, find out which one is the smallest value. No need to divide again with AR, yeah, because this is already number of moles. If you have mass, if you have percentage, then you divide by AR. Okay, but in this case, you don't actually divide by AR. You can straight away use them. Okay, so if you straight away use them, yes. Yes.
Can we use fractions in our calculations?
Fraction in calculation, yes, you can use fraction, but do not use give your final answer as fraction. It's not accepted in chemistry.
Okay.
Yeah. For maths, it's accepted. Okay, correct me if I'm wrong, but again, for maths, it's accepted. But for chemistry, the final answer must be in decimal places. Fractions are not accepted. Now, here, once you have this, okay, divide with the smallest value. The smallest value is 0.0129. Divide 0.0129. You will get 1, 2. Water, what is the value? Don't give me the whole number yet. I want to still see the decimal values. Kenneth, why you are playing with your camera? Are you calculating, Kenneth? I really want you to
7.019.
calculate, yeah? Yep. Water is
7.019.
7.019. Kenneth, if you're not serious, I will call your parents straight away, yeah? Start doing your calculation. Now, 7.09, then only you just put 7 over there, okay? So the value of X over here, this is going to be 1 mole. So this is going to be 7 moles. So the value of X is going to be 7. Okay. So the next question, okay, here for many people, an intake of 15 milligram per day will be sufficient. Okay. So they say that, okay, you can actually use this the same way. MR is given. Okay. They say that what is the mass, okay, that will be need to be taken to obtain 15 milligram of zinc. Okay, in order to do this, okay, do remember when you have let's say you want to separate this, okay, you know that in every 1 mole of this, okay, in every 1 mole of this crystal, you are going to actually, or it's better if you want to actually write it this way. I think I'll write it down this way. If they actually add with aqueous, you are going to get CH3, CO2, 2 zinc plus 2 moles of H2O. Okay, you still actually get 1 mole, give you 1 mole of this. Okay, so here they say that which one, okay, you need to actually obtain a dose of 15 milligram of zinc. So we know that even from here, okay, like every 1 mole, okay, every 1 mole of this will give you 1 mole of zinc. Okay, do remember this. Okay, this is the way you identify. So it means if I have 1 mole of this, I can, even though they separate, okay, if I actually write it down, CH3, CO2, 2, and then zinc, it's going to give you CH3, CO2, 2 minus 2 moles of this plus 1 mole of zinc 2 plus. Can you understand here? So it means whatever it is, okay, whatever it is, if you have 1 mole, you are going to get 1 mole of this. If you have 1 mole of this, you are still going to get 1 mole of zinc. Can you understand? So if I actually just erase this, if you still, this one is actually just to make your life easier, but if it is complicating, then I can just straight away use this method, okay, which is going to be, I know that every 1 mole of this compound is going to give me 1 mole of zinc. As simple as that, okay? Once you get that, okay, so I want 15 milligram of zinc. So first, okay, what we need to do is we need to find the number of moles of zinc first, okay? Then using that, we are going to actually find the number of moles of crystalline zinc ethanoate. So number of moles of zinc equals to, okay, that's going to be 15 milligram change into gram. Zinc, can someone help me with the zinc? What is going to be the AR of zinc?
65.4.
65.4. So what is going to be the number of moles?
2.294 times 10 to the power of negative 4.
Okay, so you can still write it as 2.29 times 10 negative 4 moles. So we know that, okay, we know that that is going to be the number of moles, okay. So I also know that, okay, number of moles of zinc ethanoic crystal, I just put zinc crystal, is going to follow the same number of moles of zinc. So I just put like that. So now I need to find the mass. Okay, to find the mass is quite simple. N equals to mass over mR. Number of moles is 2.29 times 10 negative 4. Mass divided by 219.4. What is the mass? How many grams?
0.0503.
0.0503 gram. Or if you want to change it to milligram also can, okay, but I think okay, just leave it, okay, in gram, should be okay, unless they actually specify. Okay, now if this dose is taken in solution, okay, as 5 cm cube of aqueous zinc ethanoate, what will be the concentration of the solution that is going to be used? Give your answer in mole per dm cube. Okay, so mole, okay, we know the mole, so we refer to this mole, okay, 2.29 times 10 negative 4, and then they say that 5 cm cube. Okay, so change 5 cm cube into dm cube. How do I change? Do remember 1 dm cube is 1000 cm cube, so you just need to divide by 1000, yeah. So it's 5 times 10 negative 3 dm cube. So divide 5 times 10 negative 3. What is your answer in mole per dm cube?
Zero point zero four five eight.
Okay, that's going to be the answer.
Sir,
Yeah,
if I get 0.0459, is it okay?
it's okay. Okay, but probably let's actually find out what might be the mistake. Yeah, so probably not using the, maybe you use, because here I use the 2.29. If you have used 2.294, okay, and which I supposed to be using, okay, it means if I'm using, it means your answer might be more accurate. So please actually, that's why if it is still 459 or 458, I think still okay. But if you have different in this, okay, that's why I normally suggest when you do your calculation, like for example, we have more significant figures, use that, the one that you have more significant figures over there, and you will get more significant figures somewhere here. Okay, so probably never one actually use this one 294. Okay, if you're using that, then if you are getting 0.04 459, then I'm okay. So it's still correct. But the idea is for everyone to get the same answer. Okay, so trying to actually get something that is very close. Okay, if it is just one number, two number, is still okay. But if there is a big difference, yeah, we cannot help already. Okay, So now, okay, we still have another 15 minutes. Okay, I will stop recording.